do this in the calculator with fn int, math 9, and it'll just give you pretty close to the answer or the answer. Um, the correct algebraic way to do it, I know that's what it says here, is you're supposed to take the limit as b goes to infinity, integral 0 to b, 2e to the minus x dx. Have you seen this notation before?
Yes, I believe so.
And so are you physically in a class or is it all online?
It's all online.
All online. Okay, what's your plan for Calc 3? Just curious. Are you going to go in person for that?
It probably would be a better idea because
I would
it's
strongly recommend that. I mean, these are foundational math courses for engineering. You really want to make sure you're maximizing this, not just getting through it. So,
right,
all right.
right.
Having said all that, you have to be able to find the antiderivative of this. How would you find the antiderivative of e to the minus x?
I'm gonna be honest. I'm pretty behind on this class. I'm also in chem.
Okay. So this is more of a Calc 1 question. That's why I kind of threw it out there to you to start. A few ways to do it. The integral of e to the kx dx is 1 over k e to the kx plus c, or you could do it as a u substitution. However you want to do it, the antiderivative is minus 2e to the minus x. And I'm happy to provide more explanation, but this is kind of one of those things like you really got to know, like this is not the calculus 2 stuff. So you just got to be really, careful here that, you really know why this is. Let me also do this here. There's a table of derivatives and integrals I always send to calculus students. I really like having reference sheets. They used to actually print out books with these, but we got the internet. We don't need that. Print it out, have a screenshot of it. I'm also going to put in a trig cheat sheet. That seems to be pretty handy. You maybe already have some of these, but I really like these. I'm not affiliated with that university or anything. I just sort of like them here. So the next step here in our progression here is you do top minus bottom, right? Top minus bottom. You learned that earlier in the course, in your previous course. Minus 2e to the minus b minus 2e to the minus 0. Limit as b goes to infinity. So on the one on the right here, it's 2e to the 0. E to the 0 is 1. Just rewriting some notation. So this part right here is 2. 2 times 1 is 2. You've got to remember what e does when it goes to infinity. So the limit as x goes to infinity, e to the minus x is always 0. These are kind of things that, from prerequisite courses you're supposed to remember, know. So this whole thing here goes to 0. 0 plus 2 is 2, like that.
And
Any
then
questions on that? That's the, I
you
mean, that's
said
the answer.
you said there's also a way to do it on the calculator.
Yeah. I mean, you've got a TI-84, which I don't have a virtual one of. I've got the virtual one of TI-83, which isn't as good, but it's math. I think it's math 9. It gives you the integral. It doesn't have infinity, but you can go like 10 to the 99 or minus 2e to the minus x. And it should give you 2 or 1.9999999. You can get pretty close. Um, I don't really remember. Is the exam through web work still?
Yes.
Okay. So nice about web work actually is it accepts numerical answers like that unless it specifies, exact. Like usually it actually does like an algorithm where it matches up your answer to the real answer and sees if the tolerance is good enough. Um, there's a million, YouTube videos on this if you want to look at that. Any questions on that?
And then real quick, where it says after I input it, it's asking for after the -2 negative EX, it's asking
Yeah,
for D after that,
yeah.
and then there's a
That
spot
that's yeah, that's X. That's X.
X. Okay.
Yeah, that's always whatever variable you're using. So even if you're integrating with respect to like W, you still use X on your calculator.
Yeah, the only thing with the calculator route is she also makes us submit our
Yeah,
work.
right. I mean, if I were grading it and you didn't have all this, I would know you use your calculator, and I would, I mean, depending how I was feeling, I would, ask you, and then hopefully you give me some sort of explanation that matched this. But um, it's pretty easy to tell if you're using a calculator or not.
Right.
So I don't recommend that, like maybe as a check, but this is a big boy math course. This is not a, Chegg course hero class. You gotta decide if you're gonna do it or not correctly.
Right. Right.
Okay. I'm hesitant to look at number three. Number three is way out of scope for your class. This is something you'll see in differential equations. It appears here because it can be done. Um, it can be done for this. So, I mean, I I guess we can do it. But do you think this will be on your test?
Um, I
I mean,
think it's gonna be mainly the 1 through 10, the behaviors of, and then a few of 12 to 15.
okay. Yeah, this is we'll just if we do another lesson sometime, we'll come back. Let's look at I don't know, number five, for example. Okay, this one has the same sort of setup as the last one. Limit as b goes to minus infinity, b to 0, 1 over 7 minus 2x dx. Do you remember at all the antiderivative of something like this or how to do it?
I do not know.
Okay, so we'll try use substitution this time. You probably saw that in a previous course, maybe in this one. So your use substitution is typically like the denominator, the exponent, a few other things. Um, you take a derivative. Can you tell me the derivative of it?
Uh, wouldn't it be 7 over x squared?
This derivative of 7 is 0. The derivative of minus 2x is minus 2 dx. It's just power rule. Okay. So the next step here is you substitute back in. So for 7 minus 2x, you're going to put a u in. You typically solve this for dx. So this is dx equals du over -2. And then you can change the bounds. That's one option here. I'm not going to overwhelm you with that, so we're not going to do that for this problem. Do you remember the antiderivative of 1 over u?
I do not.
Okay. So this is the natural log of the absolute value of u, -1 half out in front. Okay. Because there's really a 1 up here, the one in front of the du goes with that. That's -1 half. The constant just comes with it. Normally you add a c, but since we have these bounds, we're going to do that. And then we're going to back substitute. Um, so this is -1 half natural log absolute value 7 minus 2x evaluated from b to 0, limit as b goes to minus infinity. Okay. So the next thing here is you're going to do top minus bottom. It's still the limit as b goes to minus infinity. -1 half natural log absolute value 7 minus 2 times 0 plus 1 half. The negatives cancel. When you subtract that, it's positive. Natural log absolute value 7 minus 2b, like that. Okay. So this first piece here, that's okay. 7 minus 0 is 7. This is -1 half natural log of 7. That's fine. This is the real issue here. Okay. And you got to remember, what does the graph of ln look like? It looks like this, unless there's some transformations. Negative infinity, you can treat as like a huge negative number. So like whatever you want to pick, but this becomes positive. Basically, and this is wrong math notation, but it's the natural log of infinity. This is completely wrong math notation, but you can think that. You can think that that's okay. That's to the right forever. So you can think of this as 1/2 times infinity, which is really bad. This basically is what's called diverges. Now, if you were to go to your calculator and try to do this integral, this original one, if you were to go, minus 10 to the 99 to 0, 1 over 7 minus 2x dx, you would get, um, it would either give you like an error, or it would like tell you that it would tell you this huge number, like 10 to the, whatever, some number times 10 to the 99. Like there's a way to kind of know what it looks like, but any questions on that?
Yeah, so the answer is the one right above, -1/2.
Well, the answer is it diverges. And the reason it
Ah, okay.
diverges is you can't add a number. Like adding a number to infinity is essentially the same as like infinity. If you're at infinity, you can add a little more to it and it still doesn't go anywhere.
This was question number
5.
5.
Yeah. Again, I'm gonna send you the notes at the end. Um, just something to think about. That they don't always converge to a number.
Right.
Diverges is a reasonable answer here. Is that okay?
Yeah.
All right. I don't know. Do you see one there? 6, 7, 8, 9, 10, something in there that you feel like would be good to go through before we move on to like maybe 112 next grouping?
Number 10.
Okay. Are you picking that just because it's later in the group, or is there an actual a non-understanding of it?
Later in the group, and then also the square root as well.
Okay. So this one's a little different because it doesn't go to infinity. If you were to graph this, you'd see at -2, there's a vertical asymptote. So there's this whole discussion when you use these limits. There's two types of limits. There's at infinity, like when x goes out to infinity, and then there's vertical asymptotes. Basically, they're discontinuities or end behavior. So you have to know which one is the b, which happens to be that one. But that's because when you put it in there, you get 1 over the square root of 0. You can't divide by 0. That's why it's there. So its limit as b goes to -2 this time, not infinity. B to 14, 14 over. Now I'm going to do a rewrite here. This is to the 1/4 power. Okay, so if you remember, square root of x is really x to the 1/2 y, because there's a 1 and a 2 there. If it's on the bottom, that's okay. It's really x plus 1 to the power of 1. Fourth root becomes 1/4. Then you can bring it up and it becomes negative. These are all properties you learned in your previous math courses that all apply here. So take a look at that. Any issues with what you've seen thus far in this? We haven't done any calculus yet. We're just kind of rewriting.
Right. So this class uses a lot of like prerequisite math
Yes,
knowledge.
way more than calculus 1, way more. And most
Yeah.
students struggle with that because you can get through calculus 1 without really needing it. You can learn what you need as you go. This one, very heavy on that. And then calculus 3 is way harder than this class. But don't let that keep you from doing it. You don't have to be good at math to be an engineer,
Right. Yeah. Hopefully not, because
but
math is
you gotta be better than most. You just don't have to be like the best. You just have to be better than most. So,
right.
and
Right.
you're already there. You're already in calculus 2. Just you may find you've got to put in more effort than you've been doing thus far.
Right.
Okay, so the integral here, the integral rule is when you have x to the n dx, you add 1 to the exponent and divide by the new exponent. So you add 1 to the -1/4 and you divide by the new exponent. and you're supposed to write this limit notation every time. I know I mean, I find it terribly annoying, but you have to. I don't make the rules. So leverage your calculator. Like this is 3/4, this is 3/4, 14 over 3/4 is 14 times 4/3, is 56 over 3, x plus 2 to the 3/4 power evaluated for e to 14. And then you do put the top, always top minus bottom. That'll make sense in the area bounded curve stuff coming up as well. So this is 56 over 3, 14 plus 2 to the 3/4 power minus 56 over 3, b plus 2 to the 3/4 power, limit as b goes to -2. So the first one is 16 to the 3/4 power. 16 is really 2 to the power of 4. This is if you're doing it by hand. I mean, if you have a calculator, just grab it and it becomes 2 to the 8th of the 4, and the 3 over 4 cancel, just leaving the 3. So that's 8. And you have this 56 times 3 out in front. The next one here, if you, from your very basic calculus course, you always just try putting the number in. When you put -2 in, -2 plus 2 is 0. 0 to the 3/4 power is 0. 0 times anything is 0. So there's your final answer. Any questions on that?
No, I'm just gonna have to probably go
Yeah.
through it, and study it a lot more.
All right, so I picked 14 here. We're gonna go for about another 4 minutes and we'll close out. Whenever you see these in Y, you can actually treat them like they're in X for now. And then you want to figure out like where do they intersect. That's a terrible drawing. So I don't know, this one looks like this and the other one looks like whatever, but you can set them equal to each other to find the intersection points if you don't want to graph. So this becomes 2x squared equals 2, x squared equals 1, x equals plus or minus 1. So, it's they do something like that, basically. So the reason you need those intersection points is that's the bounding of the curve, the area between them. It's top minus bottom. Okay. So you have to figure out which is the top, which is the bottom. If you can graph them, you can figure that out. Or if got a pretty good idea of what the graphs look like, you can also figure that out. The top one in this case is 2 plus 7x squared minus 9x squared. And then you integrate that from -1 to 1. Again, you can go right to your calculator with this, fn int math 9, or you can do it by hand. 2x plus 7 over 3x cubed minus 3x cubed. So I should have combined these. Let me do that. That's really sloppy. 2 minus 2x squared. All right, so that'll be better. So it's 2x minus 2/3 x cubed, evaluated from -1 to 1. And you just put that in. So it's 2 times 1 minus 2/3 times 1 cubed minus 2 times -1 minus 2/3 times -1 cubed. It does not cancel. Like, don't make that mistake. You just work it out. This is 2/3. So inside parentheses here, it's -2. -1 cubed becomes -1, so plus 2/3. But then you're negating, so it becomes 2 minus 2/3 plus 2 minus 2/3, which is 4 minus 4/3. And you can make a common denominator if you want. Ends up being, I think, 8/3 is your final answer. The final answer doesn't mean much. It's just a final answer. You can also do this in your calculator. There's also a trick to using absolute value in your calculator. I can show you another time. If you get a negative number in one of these area problems, you either did bottom minus top, you did the wrong order, or something else happened. That's a kind of a common mistake. All right, we're going to stop there for today. Hopefully that wasn't too awful.